Welcome back, attendees. I believe that we did not make you wait for so long, and you are super excited for the second half of the event. So, now time to move on to the second session. Without any delay, let's begin our second panel discussion on the big tech trends shaping large scale solar. And to discuss this, we have in the esteemed panel Mr. Samir Zavaide, independent engineer. He's the moderator. Mr. C.B. Vetharaj, QI Energy Group. Mr. L.K. Verma, Power and Sun. Mr. Suhaib Al-Eni, Alda, Sustainability Energy SPC. Mr. Fabian Muller, Green Tech Energy and Water. I welcome all panelists on the screen. Before handing over the session to Samir sir, I would like to request you all again that, like the first session, any questions you would like to put to a panelist, please post them in the Q&A box. A panelist will be taking those questions at the end of the session. Over to you, Samir sir.
Thank you very much, Vishali, and big thanks to Solar Quarter for their exceptional work in the solar PV sector. And big thanks to all of the organizers that are behind the scenes. We start our session with a fantastic group of panelists. Mr. CB Vita Raj, he's the manager and business development and operation for Key Energy Group. Mr. CB, are you with us?
Yes, I'm here. Very nice to meet you.
Mr. CB is currently working with Key Energy, which is a mounting structure manufacturer since 2018. He has more than 7 years experience in the PV industry, combining the experience with from IPP as a consultant and as a technology provider. And he is working together with a big group of people, experts in the Solar Clean Tech Business Club, and he is a manager for the Middle East. The Solar Clean Tech Business Club is a global network of clean energy professionals. So big thank you for being with us, Mr. CB. And we like to start by asking you about the solar industry growth in Oman and in your country of resident in UAE, and versus the impact on the mounting structure technologies. Go ahead. Over to you.
Thank you so much, Samir, for the introduction. And it's a pleasure to be here amongst all well-known panelists here. So, as Engineer Samir mentioned, I'm more from the mounting structure manufacturing background. So, I would like to give a comparison, like a small note about how the industry is growing in terms of capacities and how does it impact in terms of mounting systems. So, because it's a common idea that people usually think, okay, mounting systems, okay, it's just for putting panels on roof or ground or water. But so it's just steel rails. That's all they think properly. But the thing is that there are a lot of engineering stuff that goes inside the engineering of mounting systems, and to make sure this is fit for purpose. So I would like to give some insights about how the solar industry growth is impacting positively, as well as a little bit as a stumbling block for EPCs in the solar market. So as we see now, like solar, it has improved in terms of technologies from poly to mono PERC, and in terms of efficiencies, which were very low, and now to massive efficiencies these days, like nearly double from last couple of years. So this is going on one side. Then the module sizes are increasing, which means the wattage is increasing, and coupled with increasing efficiency, we are getting 660 watt peak, 750 watt peak modules these days in the local markets here. And in terms of locations, ground mount or a normal rooftop has been changing continuously. We started doing solar car parks, then we started doing floating solar projects. So wherever, like whatever the situation is, wherever the location is, so the solar industry is constantly improving and growing in terms of satisfying the client's needs. So in terms of location also. And in addition to that, we have cleaning robot technologies, advanced O&M technologies, and a lot of other new techniques that are coming in into the solar industry. So as we can see from the last few years, we have been seeing an exponential growth in terms of capacities. Governments have been changing their regulations to accommodate solar, so net metering and a lot of stuff going on in terms of solar industry. And in addition to that, we have even seen like a 10 years PPA now have become 15 years. And in some places, the 15 years have become 20 years PPA. And in Europe, it's getting even more longer. And when the duration of PPA is increasing, probably this puts the pressure on the developers as well as on the EPC contractors who are going to do the project. So this is the positive side of the solar industry growth. What has it become in the last few years? But the issue with this is that it also impacts on the mounting system. Though the panels are getting bigger, it has to be noted the weights are getting more also, which means the structures has to be improved along with the improvement in terms of modules. So the clamping points of the panels, which were different previously, are now very crucial in terms of based on wind load, based on snow load, we have to make the clamping points accordingly, or if not, the warranty on the modules will be void. So these things have impacted the design of mounting systems. And in addition to that, like we see, we are improving a lot of O&M technologies in the solar installation, which means we have to take them into account during design of the systems. So which has led to the for example, if you say tonnage per megawatt, which has increased a bit because we need to accommodate the bigger size modules. We need to accommodate live load due to the cleaning robot solutions and everything to design so that the system works for the 25 years lifetime or 35 years. And also because the PPA terms have been increasing, it puts tremendous pressure on the mounting structures that we need to design our structures accordingly to satisfy 25 years of lifetime, if not 35 years of lifetime. So this has been impacting on the mounting systems also. And as I mentioned, this is a stumbling block a bit for the EPCs because at the end of the day, EPCs have contracts which were signed long back when they have to revise it to new technologies and new systems to be incorporated, which this puts a pressure on EPCs in terms of price as well as quality of delivering. And in terms of, I've seen a lot of developers, they're putting performance guarantees on their EPC contractors whenever they are doing mega scale projects. So in short, though we can see the solar industry has been growing exponentially, we still have a pressure to be handled by the technology providers like us who are manufacturing mounting systems. But the good note is that we are constantly doing R&D. We are constantly developing new systems, and we are constantly developing our technologies, how to serve our clients more better from what we are serving right now. So I, with this points in mind, I leave it to Ijay Samir, so he can take it from there.
Thank you very much, CB. It actually talked about many things. And the next question I like to ask is about the selection of the mounting structure technologies.
Okay.
Can you tell us about the typical systems that you are installing, let's say, for the decentralized systems, the on-grid, and for the utility scale? What are we seeing? What should we see in the next, let's say, 5 years for the decentralized and for the utility scale project as far as mounting structure technologies? Thank
Yeah,
you.
sure.
Over to you.
Thank you. So this usually when you ask a technology provider like us to design a system, they will ask you a couple of things. Where is the location? What kind of terrain is it? What is the coordinate? And what is the solar panel that you are planning to use in terms of the project specific solar panels, like whether it is 540 or 650 or 740. So they will ask you these questions and then they will come back to you with an answer. For us, what we have seen in the recent years is that
engineer,
previously it was it
senior available للبارت تايم ورك حواليك هيك هذا شغال.
Okay.
so
That
yeah
was good. Yeah.
so
Go ahead.
so what we have come across in these days is that we are asking for the same questions, which is the area of application, coordinates, and module sizes. In addition to that, we are also asking, we are also looking from the project specific background, which is like, okay, if it is a ground mount, for example, if you are saying there is a 50 megawatts in Oman, where you need single axis trackers or ground mount fixed it. So we ask the same questions, but in addition to that, there are a few questions we need to look at it, because the way the mounting systems were progressing is that it was very stagnant for many years, and now it's constantly improving with the big module technologies. Because, for example, if you tell me that you're going to use mono-PERC modules, it's a different kind of mounting systems. And when you say it's bifacial, which is like you have a bifacial gain, so you have to design your module mounting structure in addition and according to that, so that you get the set bifacial gain. So these systems, or these technologies like bifacial and things, they are constantly allowing us, they are helping us in terms of constant R&D in terms of mounting systems. So depending on, not only depending on the module sizes, not only depending on the terrain, the mounting systems now need to be designed based on what kind of modules to be used in the project. So this is always an issue for developers as well as contractors. So to answer your question, like what is the kind of system that we are going to see in the decentralized systems, uh, we are going to see a lot of fixed tilt ground mounts, because previously it was tracker was dominating the market in terms of utility scale projects, 100 megawatts, 200 megawatts, 300. But just before joining in the call, I was having a discussion with one of the developers who was looking at 100 megawatt project. He was looking at with trackers. Now he's changing to fixed tilt because of the lot of issues with O&M technologies in trackers. Because when you simply ask and allow someone to lead you in terms of tracker business, everyone has their own way. Market developers, kind of like market developer from UK or Europe, they kind of give you a proper solution in terms of technology for the trackers, rather than friends from some different countries in the world. So there is still a lot of issues there in terms of tracker technologies, operation maintenance of trackers, putting guys separately in the site for handling this tracker O&M. So there are a lot of myths that needs to be taken care in the domain of utility scale solar projects. But cutting in short, uh, what we see as a near-term solution for a decentralized project is that it's going to be fixed tilt, which is cheaper in terms of cost when we compare with trackers. And this is going to be robust, which means like it doesn't have any moving components, which means there is no O&M, and it might be the cheapest as well as the best option for developers in the coming months, I would say.
Very good, very good. My last question is about the let's say the way forward, and your recommendations for owners and developers that they want to buy your mounting structures, or buying mounting structure in general. What is your recommendation for best practices?
Yeah, thanks for the question, Inja Samir. So, thing is that to every problem there is a solution. So it should happen. Like there is a change that's currently happening, which is the module technologies are improving constantly, efficiency is improving. People, there are a lot of players in the mounting structure domain, and people are constantly doing R&D and developing the systems, making it cost efficient, bringing down the LCOE. But things also should be, there are certain things that are still lacking in the market. I would say the first point I would say is that lack of education of the technology inside the contractors domain or developers domain. We can see big project developers with big experience, but they may not have the required expertise in everything. They may be masters of module technologies, inverter technology, but may not be mounting structure. So from the mounting structure point of view, they always look at, okay, what is your cent per watt? That's what they look at. They are not going to look at, okay, if I am buying this at 7 cents per watt, and what are the related costs, like what is going to be the site installation cost, what is going to be O&M, and if I am buying at 8 cents, what is going to be my site installation cost, and what's going to be my O&M. So this question is still lacking, and this is one of the reasons why people are struggling a bit with the mounting structure domains. And rest assured, when we have discussions with our clients, we also tell, okay, this is the best way to do it. This is a little bit on the premium side, but it negates all your risk during installation, and also it puts your price down on the civils part. So we kind of educate our clients, we enable the clients, because clients already know mounting systems. But thing is that we have to give them an update about, okay, what's going on, what are the issues that they will face if not done in the right way. So we constantly educate our clients. So from my point of view, the next way forward will be like sitting down with your client, explaining them, okay, this is the way it should be done. This might be 1 cent higher, maybe 10% higher, but it will reduce your OPEX cost. Because right now, what the issue is faced by contractors is that they have been seeing the projects from an EPC contracting point of view, where they look at capex, they don't look at OPEX. So when they look at OPEX as well as CAPEX together, then they will come and arrive at a good solution, which may be having a higher CAPEX, but it will put down your OPEX cost very low, which is very useful for the life of the solar project. So because we are planning towards 25 years, 35 years lifetime, so we should be taking into account CAPEX and OPEX and design our systems accordingly to be able to get things moving properly in the right way. So everyone has a part to play, and yeah, we should, whether we like it or not, we have to play the part and get more sustainable projects.
Wonderful. Thank you very much, CB. And I hope one of these days I attend one of your capacity building seminars. I think that will be very interesting for a lot of engineers.
Thank you.
Yes. Thank you very much, CB. Mr. Verma, are you with us?
Yes, very much, sir.
Excellent. Very happy to see you again. It was wonderful seeing you in Jordan last month. Mr. Verma is the founder and managing director of Power and Sun, wholesale solar component distributors in the Middle East. And they celebrated the 1 gigawatt shipment of products this month. Largest distributors of Longi, JA Solar, Trina, Sungrow, Apar, Clean Energy, and so on, with 30 years of experience and 18 years in the corporate world and 12 years as an entrepreneur. Mr. Verma, it's always wonderful to see you and talk to you. I like to ask you to give us your best advice to procurement professionals when seeking to procure solar PV system components. Over to you.
Thank you. Thanks for the session and actually moderation, Mr. Samir. It was really a nice and to know about you and Solar Quarter coming together for these webinars is going to certainly help all the stakeholders of a solar industry. See, supply chain has its own role in a solar industry, in a renewable industry. And when I say its own role, I talk with the confidence that 75% of time, cost, and energy is actually spent in making the materials available to the site. So this 75% of cost and energy, if you are spending in making to the site, and if this is being managed well, there will be a lot of cost reduction. There will be a lot of waste elimination. There will be a lot of waste elimination in the form of time, not only in the form of money and material. Now, this can be managed not only by looking at the price perspective of procurement. It has to have a holistic view of time, cost, and quality, all the three basic dimensions. What is the time overall you are spending in making the materials available to the site? From the time it is decided to procure, and then at what time it is available for our supervisors and the installers to install. That's a complete time which is required to be monitored. Cost, of course, it's not only the pricing of the components, but the overall cost, including the ideal time of the projects, because most of these projects, if it is a 1 megawatt project and a team has to wait for 1 week for getting the components in place, you can understand the cost which is actually built up, which is actually unvisible. But when you put it on a spreadsheet, you will realize that the amount of money you have wasted in waiting for the material to reach in time. So time, cost, and of course the quality of not only the products, the quality of the transactions, quality of terms, what you negotiate with the suppliers. So if these three dimensions are controlled, time, cost, and quality, I'm sure the overall cost of a solar project can reduce by at least 2 to 3%, or maybe sometimes 5%. And more importantly, the time of project turnaround time should reduce by at least 30-40%. And this can be achieved not only, I mean, if we have a couple of supply chain experts or supply chain professionals in this. There's something called as a master planning, which is being done right from where to deploy the inventory, at what levels it has to be deployed, when what are the components criticals, what are not critical. So in the master planning, all these things are getting addressed. So, coming back on your question that what should be the advice, I think a holistic view has to be achieved, a comprehensive plan has to be made, and I'm sure from the existing level, at least not less than 3-4% or 5% of cost reduction, and more importantly, minimum 30 to 45% of a time reduction in a project turnaround time.
Excellent. I have two more questions, Mr. Verma. The first question is related to the current geopolitical situation and increase in price in logistics, fluctuation of the international oil prices, and impact on deliveries. When EPC contractors they need to give prices, they are suffering now because of this fluctuation. So my question is, what is the best advice that you can give procurement professionals on companies on how to deal with this fluctuation in logistic prices and time of deliveries? Thank you.
Yeah, thanks. Thanks for your question. I'll put it in two parts. First is, let's understand the fact, especially in the Middle East, we all are in a very dynamic or unmatured market, solar. The if you talk about PV modules or inverters, every 3 months to 6 months, the technology is changing. Every technology, when I say that there is a product upgradation or new products are coming every 3 months to 6 months time. The sea freights, which used to be 1% or 2% of the overall consignment, or 3% maximum 3 years back, is today playing a significant role of 7 to 8%, or sometimes even 10% of the overall consignment. Now, these sea freights are also changing, within a period of 40-45 days, if I have to speak, or maybe even 30 days, between China and Dubai, or between China and Middle East. I think 4 times the price corrections on the seas has taken place in up and down. Once it was almost at 8,000 level, then it reduced, then again gone up, then it reduced, then again gone up now. So there is a one side where there's a fluctuation on the sea freight and these arrangements. Then there is a product which is changing every 3 months or a 6 months time. So given these two situations, the procurement managers has to plan and meet the timelines which has been given by them from the project team. The best way of handling this is actually handling this in pieces, rather than trying to take the complete the pie, trying to eat it in one go. And when I say the pieces, means the small jigsaw puzzles, solving the entire problem. It all starts from like when and what material which is required, which starts from the alignment of the demand, the actual demand, the alignment of that. When I say the alignment, means if there is a project, whether it is 545 or 540 or 550 watt peak or 600 watt peak, so which product, the information has to be in advance, that what product is available in a quarter wise. Most of the PV manufacturing companies, they release their quarterly production schedules with respect to power bins in advance. So this information is must. If a project is designed with 535 and 535 is no more going to be available after 3 months, then entire exercise, you need to redo. So first is the alignment, which is from the project design alignment to the availability alignment. Then creating a master plan again of the shipments and other things, and possibly, if possible, if a EPC company has couple of projects, so start deploying the inventory even in the transits. So if because from China material to reach over here, it will take at least 3 weeks to 4 weeks time, and this is a good enough time to deploy it for project A, project B, project C, and project D. So these are certain areas of planning. Of course, the only way of handling this is planning, and planning in supply chain has many practices and principles which can be deployed. I mean, there are industries from where we can learn, like automobile industry, from a laptop, or from your computer industry, where the supply chain has reached to the highest level. Everything is getting assembled in one place, and then you have you have actually the best of the concept JIT and all those things. Not now, almost 40-50 years back, they were actually practiced. So these are certain areas which can be actually used. Unfortunately, the supply chain as a contribution in a solar industry is at a very limited, or at a very very minimal stage. I'm sure with time and with as the industry matures, these things will also improve and things will happen. I think you also asked on the second question. What was that? Can you just
Yeah. The second question and the final question is, we have another 2 minutes for your segment. What are the most in-demand items that, let's say, engineers come and ask you, and the goal behind this is to identify the spare part list. So we want to give some advice to project developers to have some spare parts items for big projects. So what are the spare part items that you are recommending? For example, PV modules, inverters, cables, blah, blah, blah. So over to you in 2 minutes.
Yeah. Very quickly, let me just explain to you now. If we talk about, basically developers or EPCs or the installers or the distributors. So developers has a different altogether way of handling it, because at one point of time they handle many projects. EPC may have less number of projects than the developers. So with this background, let's understand one thing. Any inventory, if it remains in a system, is a cost. It's a money blocked on the components, which can be realized immediately or cannot be realized immediately, maybe in a longer time. So I'll not suggest for an EPC to hold the stocks of the components, because the cash flow will get hampered. It's what is important is, like, all the components, the BOQ, create a 1 or 2 tier suppliers for it, especially locally, so that you reduces a lot of time in procurements. Europe has been very successful on these models. In fact, there are many EPCs who would not prefer to buy it from a manufacturer. Even for a larger projects of 5 or 10 megawatts, they prefer to buy it from a distributor, because they understand the value of the inventory and the money blocked, the money which gets stuck in this region. So I'll say that no need to create inventory lists. Create a reliable vendors, or the suppliers, preferably the distributor, and that's why Power and Sun plays an important role. Just a small correction: in a 1 gigawatt shipments we have reached in the last 5 years. It's a consolidated shipments in last 5 years from Power and Sun, which has reached to the 1 gigawatt in this month. So
Very smart answer.
Play the role, yeah.
Uh, very smart answer. Why keep stock if you can buy from Saman Power and anytime you want? So, very interesting. Excellent answer. Thank you very much.
Thanks.
Okay.
Thanks a lot. Thank you.
Thank you, Mr. Varma. Over to Mr. Suhaib. Mr. Suhaib, are you with us? Mr. Suhaib?
Yes, I'm with you.
Yeah. Excellent.
Yes. Hi.
Uh, Hello, Mr. Swaib is a
Yeah.
co-founder and CTO of Aldao Sustainability Energy SPC Holding. He has a master's degree in industrial power, specialized renewable energy integration from the University of Technology in Malaysia, Malacca, with 5 years experience in power system in Oman and Malaysia. And we are going to start by asking you a question about how large-scale projects, solar PV plants will look in 2025. Over to you, Suhaib.
Okay. The largest will be good. In Oman will be like around 2 gigawatt as per now for the biggest projects, because it is like we have already 500, and now they are planning in the government and OPWP to increase of 1.5. So it will be good in this one, but this is the
Okay.
okay.
Okay. Very quick answer. Okay. Another question
Yes.
about the latest technologies in modules. And what are the expectation of project owners in the futures?
The expectation of the owners, the high quality and the models that followed the the IEEEs, because here in Oman also they are only accepting the models and the inverter that follows the IEEE things,
Hmm.
IEEE standard.
Okay. Uh, did you do any certification of these PV plants? Are you doing any certification?
PV motors or PV? Hmm?
The complete plant, to make sure that it's operating correctly.
Yes.
Do you have certification of the complete plants in Oman?
Uh, Not me, because I'm consultant, but I know about, because we have a connection with authorities. So we have like the every project is around 500 megawatt,
Mhm.
and also there is this is connected to the grid of the MIS grid in Oman, because as you know, there is two things in Oman. There is MIS and there is the FAR is they have their own grid. So it is already connected to the main interconnection grid. So this is the 500. And now maybe within this year we will start with the 1.5 giga in Manah. This is a project that divided into two categories. One is 500 and the other is around 600 megawatt.
Okay, and what kind of technology are you using? Is it fixed or a single axis tracking? Is it
Uh,
by?
in, in every they use the both, and divided into scenarios, and so they use the but proper way for the solar things here in Oman is they using the fixed angle.
Okay, so it's fixed. How about the cleaning? How are you doing the cleaning for these big projects?
The cleaning for for a small project, they are using the normal cleaning things, but for the biggest project with the mega, they are using robotic. And if you hear about the Shell program, there's one of schools also for the in a small size that are using also the robotic as an example, not full.
How many big projects do you have in Oman so far, and how many are we expecting in the future?
For a biggest project, it varies. For there are around 2 mega for Mall of Oman and 1 mega with KMG store. So this is the biggest of the project in utility scale, and in a very big scales, 500 that is connected with OPWP system.
What is the percentage? Do you know about the percentage of electricity generated from renewable energy in Oman?
Now, yes, I think Nama Group already published this one. I think for the wind, they are here in Oman around 6%, and with the solar, I think 5 also to 7%.
Okay.
But they now it's expecting to 2030 to reach around 30% of the demand.
Okay. And this 30% is going to be mostly large scale projects or also small scale projects?
Small scales, because for the large scale it is very complicated, because we have only here only one company that can purchase the power. So it will be in a very low capacity for the project with the high scale.
I see. I see. Okay. And what is your recommendation as a consultant for consumers who want to install solar PV? Do you encourage them? And what is the duration for development of a, let's say, small scale from design, getting approvals, installation, and commissioning? Over to you.
Yes, we recommend, and depends on the behavior of, because they need to start checking the behavior of their own, and how they can reduce the bill of electricity. And regarding the duration, um, it's around 2 to 3 months to install the things, to getting the approval and install the things.
Wow, that's very quick.
Yes,
Okay, Mr. Suhaib, thank you very much. And I'm sure we'll get back to you with some questions.
sure.
Mr. Fabian, are you with us?
Yes, I'm with you. I'm
Excellent,
right
excellent.
here. Thank you, Mr. Summer or Engineer Summer, for hosting this event with us.
It's a pleasure. It's an honor to be part of this esteemed panel. Mr. Fabian is originally from Austria and having spent a total of 16 years in Oman on and off. In 2017, they formed a green technology company catering for Oman's need with state-of-the-art technology from around the world. He is the managing director of Green Tech Energy
About your
and
project.
Water, and they specialize in renewable energy as well as sustainable water technologies. It's an honor, Fabian, to have you here. Uh,
My
we'll start.
pleasure.
Thank you. We'll start with a question about the advantages of large string inverters for commercial, industrial, and utility scale plants. Can you tell us a little bit about that? Over to you, Fabian.
Thank you very much, Engineer Summer. Well, as I'm sure many of you already know, the old trend was to build larger plants with big central inverters, combiner boxes, and single direction, single MPP tracker models. While the central inverters are still very much a thing with the ultra large scale utility plants, even those are tending towards the string inverter model for various reasons. Um, Primarily, the speed and ease of installation is one of the major advantages that a string inverter holds. Um, I'll get to the size a little bit later, the sweet spot, so to speak. But the speed of installation, as well as the flexibility and ease of installation for what we like to say regular installers or regular electricians, as compared to the highly technical central inverters, is an advantage, as well as the redundancy factor that smaller units bring with them. Um, for example, if you have let's say a 5 megawatt plant and each and 5 times 1 megawatt central inverters, if you lose, if one inverter goes down, then you lose a fifth of your output, which may take, as Mr. Verma said, delivery times and delivery costs are not in our favor at the moment. It may take months to replace. Whereas if you have a string inverter or two go down and that effect, you may keep a spare on site, or you're very likely to keep a spare on site, and you can have your lost capacity up and running within several hours at most. So that's a major advantage. What we also recommend to our clients when they ask whether to go central or to go with string inverters. Also in our lineup, we're keeping the full range of Huawei inverters. That's who we are representing as well in Oman, together with our partner Solis Depot. And especially in that segment, there's the 800 volt range, which is already considered medium, or is it low to medium voltage, where you have a large size string inverter with around 200 kilowatts, all feeding a plug and play kind of central transformer station. And it can be set up in a fraction of a time of traditional central inverters, and also mix and match kind of string inverters and independent transformer stations. These plug and play solutions and self-functioning, well-functioning, how do you say, engineered from the get-go solutions are what I believe is driving the future, because the costs are coming down and further down. The price pressure we are experiencing as developers and EPCs is very strong, especially in a developed markets. You feel it even more, where there's a lot of competition. And unlike many dubious offerings out there, we refuse to how do you say, compromise on our quality. So we have to find other ways to bring the price down, and that's why these plug and play solutions, which may cost a little bit more in capex, they're very, very useful, because everything is almost pre-commissioned for you. You just plug everything in, and even remotely they will assist you from the headquarters of the company, and within several days you will have everything commissioned, rather than possibly even several months to iron out all the issues of untested systems. So definitely the soft costs can be greatly reduced by using larger string inverters. One question I often get asked is why do, for example, Huawei limit themselves to around 200 kilowatts, whereas other companies are offering 250 or 300 kilowatts inverters? This is not a technical restriction that they have. They made an informed choice on that, or a decision, because there is, of course, a sweet spot. Where does it go from being a string inverter to more of a central inverter, and where does it become very cumbersome to handle? Like the weight of the 300 kilowatt inverter is very heavy and cumbersome to move around, whereas the 200 kilowatt is still manageable with some light machinery and several installers. the shipping ability, the space requirement, and of course the way it fits into containers for sea freight shipping. All of those things need to be considered. So of course there are limits to the size that should be built. Um, Other advantages, I would say, for certain brands of string inverters is the IV curve tracing. As you hear often now, there's a lot of plants which are going into mature stage or semi-mature stage. They've been running for a few years. Problems may be starting to arise, and people are noticing maybe that generation isn't as it should be traditionally, or in older, or in, how do you say, legacy plants, you would have to employ specialist consultant or testing engineering company to come and test each string individually for their IV curve performance. Now our inverters that we offer it as a service. IV curve tracing directly inbuilt into the inverter. You can run a test remotely from your office, can be thousands of kilometers away. You have your plant under control. That, of course, can't be done with the bigger inverters and with the old legacy type of devices. Um, so again, coming back to it, it's all about user friendliness, speed of installation, speed of diagnosis, pinpoint troubleshooting, and I believe that's where the future now lies, because you tend to reach a price floor, if you will. It can't really get much cheaper to a certain point unless the quality starts to suffer, which is not in anyone's interest, really. Where you must find new and innovative ways to improve your client or your customer's experience. And yeah, that's pretty much the wrap up to why we believe, or why many people, of course, believe that string inverters are the future for even very large scale plants, 500 megawatts and up.
Definitely, and very interesting. And I'm sure that the string inverters they can go up to 300 plus kilowatt nowadays.
They
So
can.
it's they're catching up. But with the features of flexibility and this the self diagnostic, it's very powerful.
Thank
And
you.
yes, we have another question regarding the solutions to the classic intermittency problems that affect solar PV plants of all sizes, especially the larger ones. Can you tell us a little bit about the intermittency problems? Thank you very much.
Yes, absolutely. It's a good question. The thing is, as you know, especially now with the geopolitical situation, energy security is a major factor. It has been always historically, now even more so, as countries are demanding energy security. At the same time, they must wean themselves off traditional fossil fueled energy uh, rather quickly, let me put it that way, as this current situation in Europe is showing. They're all scrambling to replace their gas fired electricity generation with renewables. That's why nobody can buy any inverters and any panels. I know it's all out of stock around the world because Europe is demanding all the stock, and coupled with COVID and these transport issues and chip shortages, and it's a bit of a perfect storm in a sense for our industry, unfortunately, at the moment. Nevertheless, it boils down to the intermittency issues of solar. Even on a perfectly sunny day, you have the intermittency. Obviously, you don't produce enough electricity in the morning, in the evening, and none at night. So for the average homeowner, I mean, it's going to the sense like, I mean, it's a European homeowner with no heavy AC loads in their building. They already several years ago began to install batteries, 5 kilowatt hours, 10 kilowatt, 15 kilowatt hours, and within the summer, spring, summer, and autumn months, they were able consistently with nice weather to pass throughout the evening. Using only their own generated renewable energy, which is fantastic. Um, Even it's not so much a financial question at that point. I'm talking more about diehard environmentalists who really want to use their renewable energy at their premises. That's how it starts, but it doesn't tackle the major issues of industrial power requirement, commercial power requirement, winter and transition months. Winter in Europe or in other northern latitudes, there's notoriously little solar irradiance. I mean, Germany, Austria, these countries are still mid-Western Europe. If you start going up higher towards the Scandinavian region, you maybe get a couple of hours of sunlight in a day in the winter. So they're literally sitting in the dark throughout the winter. These kind of countries, once they wean off completely, they'll start really having issues. I mean, the Scandinavians have their hydropower, which they are lucky to have. That's good. What I'm trying to get at the end of the day is we need to develop large-scale storage, seasonal storage quickly. And by quickly, I mean immediately, in order to transition as fast as possible. And what I mean with large-scale seasonal storage, there's new things in development now. I've read a little bit about sand batteries using to store heat for heating in winter, with heated by solar PV in the summer and autumn months, and the sand carrying the heat all the way through to mid or end of winter. There's other things you can convert it to. As everyone knows now, it's a big hype to hydrogen, green ammonia, running traditional power plants with that. Of course, the lithium batteries that everyone is talking about that are being implemented at a large scale. For me, lithium is a great technology, but it's more to replace the short bursts of energy, to handle peak demands, to stabilize the grid, these kind of things. Real long-term storage, I'm more looking at things, like I said, the sand storage, but also pumped hydro, where in Switzerland they opened I believe it is 20 gigawatt hour pumped hydro storage unit, which can support Switzerland throughout several days and nights. And the point is, that is a long-lasting technology as opposed to lithium batteries, which maybe have a lifetime minimum 10, 15, maximum around 20 years before you have to reinvest. And these kind of pumped storage units have lifetimes of 80, 90, 100 years plus. And then, of course, you'll have the traditionalists saying, oh, but it's very expensive. It'll cost you, this particular one costs about, I think, $3 billion. But if you look at a traditional nuclear power station with a 1 gigawatt capacity will cost you minimum $5 billion, storage not included. And of course, we don't need to start about the dangers of implementing nuclear power stations. So the point is, it's not one true solution. Also, hydrogen and green ammonia, while they're being hyped big time, especially in the Middle East, Oman included, are not one solution. It needs to be tied in together while we wean off the traditional hydrocarbons. We need to utilize batteries. We need to utilize ammonia and hydrogen, green ammonia and hydrogen, pumped storage, other forms of storage, so that it can be there's a safe baseload for all especially our industrial needs.
Okay, wonderful to hear this detailed advice. And yes, the world is moving towards storage at an incredible pace. And actually, this year is I always call it 2022 is the year where the solar PV module manufacturers started offering the storage solutions. So this is a base year in the solar PV industry, and hopefully we will see storage at many levels. And thank you for bringing up the project in Switzerland. Actually, the 20 gigawatt hour is amazing. We have to read more about this project.
Fantastic, yes.
As you know, Fabian, the Solar PV project takes about maybe, let's say, 2 to 3 years in design, development, and financial closures. And then you have 1 year maximum, let's say 18 months of construction. And then you have the PV plant running for 30 years nowadays, because the solar PV modules are coming with 30-year manufacturer warranty. So can you tell us your views on the importance of quality of the material used in the construction and the best practices for the industry? Over to you.
Thank you very much, Engineer Samar. Yeah, as you mentioned, I mean, warranties or longevity even are increasing to the point of 30 years. There are some module manufacturers who even offer a product guarantee for 30 years, 30 years of product guarantee and 30 years of performance guarantee. These are all these are all well and good, and they're required, and they all contribute to the what they call it, the bankability of the product. But what I really mean with quality, in the sense, there's two things. There's the quality of the material, and of course, there's the quality of the engineering, and I suppose the quality of the installation. Three things all need to be in unison. And I did a lot of research into various quality aspects and where improvements can be made, and I researched all kinds of module manufacturing methods, materials, bills of materials, to the point where the module manufacturers were accusing me of some industrial espionage. Well, I was just really interested to improve my own business because I'm using their product. Anyway, we had a good laugh in the end about that. But the point is, the problem lies mostly in the smallest details, and I like to talk about the connectors that are being used. That's where I believe one of the biggest problems lies, in people using the wrong connectors, or intimating MC4, or not actually MC4, imitation connectors. While an imitation connector can be used if you use the same male and female positive and negative connector and they mate properly. How well they mate is another story, but as long as the brand is the same, you're running a less of a risk. Once you start intimating what looks the same, an imitation connector with, say, an original MC4 connector from Stoibli, that's when your problems really can start. You may get lucky and it may fit. You may most likely will get unlucky and you will have a connection that works electrically. You'll switch on the system. You probably won't notice any inconsistencies. But what's happening there? You have a loose connection. You have a very high point of resistance. You get heating. Those points start to fail down. I've seen collectors burned completely to pieces with arcing, and earth faults are occurring, down to the whole building and roof catching fire simply because of a $1.50 item, because somebody bought it for 50 cents. And that's what I always tell my client. I was like, if it comes down to those few cents, I'll happily give you that on my costs, so that you can sleep under your system. I can sleep in my bed, not having to worry about you, just because of a 50-cent item. But that's also, it goes throughout PV and many industries. Where 50 cents can be spared, they will spare it, especially in manufacturing companies, countries like China, where it's often unbelievable how cheap they can make things. You can't imagine how they are able to make something like that. I'm sure all of you have been in a China Mart or somewhere, and you're getting angle grinder for 50 dirhams. I wouldn't turn that thing on if it was 100 meters away from me, to be honest. So how do they make it that cheap? Is because they save on every cent, and they do that with your high quality or supposedly solar modules as well. That's why even you get a certified bill of materials, if it's made in one factory versus the other, the bill of materials is exactly the same. It's just the the supplier of this bill of materials is slightly different, already you're getting a different module. I've seen like entire module fields fail with identical BOM where the other one is still operating after 15 years. This one has failed after 5 years. So I can't stress enough the emphasis of quality, especially in this region where we live, with some of the strongest UV light in the world, the strongest sunlight in the world, extreme temperatures. We're talking a real stress on this material, and that is what I try and convey to our customers, both for when we are selling them complete systems, whether we are developing our own PPA and lease developments, or when they are buying just simply inverters from us and they're asking me, Mr. Muller, shall I go for this cheaper non-name brand inverter, or why should I buy your product? I tell them exactly these things, and at the end of the day, it's their money they want to spend. Yeah. So, but I try to give my best advice, and that's why I'm also sharing my views and my inside knowledge with you all, because I believe to improve the industry as a whole will benefit everyone individually as well. Which I don't want solar to have a bad name because people are cutting corners. I'm sure you will all appreciate that. Thanks
Thank
very
you.
much.
Thank you very much, Fabian, for this wonderful recommendations. Really appreciated. Vishali, over to you. Do you have questions for us from the audience?
So we have three questions, but I think everyone has answered.
Okay.
CP sir, have you answered these questions right?
Yes, yes, I have done. Yeah.
Yeah, even one is for Mr. Suhaib. He has also answered.
Okay.
So
Then, yeah, we can ask more questions from our esteemed panel. No problem. I have a Mr. CB. You are the lucky one with the next question.
Nice.
Are you with us?
Yeah, yeah, I'm
Yes.
here. Yeah.
Can you tell us a little bit about your metal structures? Which
Just hold on a
What
minute.
do you prefer, the aluminum or the steel structures?
Yeah, thank you for the question. Actually, to be frank, it's always based on the projects actually. So, based on, let's take Oman for example, and maybe experience from Dubai, we can take into account. So here, the conventional way how the utility scale works is that it's all steel ground mounts, ramming systems, and using ramming machines and stuff outside because point number one, it's easily available here, the installation equipments, and also it's easy to find skilled manpower in those domains. So for utility scale, I'm pretty sure the steel ramming ground mounts, sometimes maybe it's trackers or fixed tilt, that's going to be the stuff right now. But for commercial scale ones, I would say where the scale is like less than 5 megawatts or 10 megawatts, the best stuff here is that when you take into account the concrete availability of concrete and the raw material steel and stuff locally here, the best one is aluminum ground mount probably because we have done a couple of ground mounts here and it's all aluminum. It's very easy. It's made in Dubai and supplied between we supplied for projects in Oman as well as we supplied for projects around the region. So for us, for commercial scale projects, the best solution is aluminium and using concrete foundation. So this is the answer to be short, actually, as per our experience.
Thank you. Thank
May
you very much.
I add something to that, Sibi?
Yeah, sure.
Yes.
I believe, as far as I can tell, they require you to have aluminium structures on the roofs here in Oman. So they, even if you come with steel, and steel is easily as good, depending on whatever application you're using, they may ask specifically for aluminium, citing corrosion related worries. Even if it's galvanized steel, they prefer to have aluminium. That's just one of these quirks that they have. On the ground, mind you, the steel is fine.
Yeah,
Whatever.
yeah.
I think there's more corrosion on the top of the building, but that's just how they like to handle it. Just for anyone in case they are wondering about that.
Great.
Okay. Mr. Verma, are you with us?
Yes, sir. I'm with you.
Excellent. I have a question regarding the available, let's say, off-grid material. Because do you see a requirement for the off-grid systems in the Gulf region? Over to you.
Yeah. Definitely. I mean, I see the requirement for both off-grid as well as hybrid. Off-grid is for sure. There are countries in the region where the houses actually doesn't have a power, or there is a massive power cuts. So for a very economic houses where they cannot afford the solar, but they can have a battery and an inverter, and it's being charged whenever the power comes on a battery basis. So off grid is we have seen it in a specific pockets, especially in a Levant area, off grid requirement coming up. Uh, I also see there is a good possibility of a storage system, may not be immediately, but maybe 1 year or 6 months down the line, because energy independence is gaining, prominence.
Okay. Thank you very much, Mr.
Thank you.
Mr.
Thank you, sir.
Yes. Mr. Suhaib, are you with us?
Yes.
Mr. Suhaib, I have a question regarding the testing requirement for connection to grid. What are the requirements for testing commissioning of the solar PV system before connecting to grid?
There is two things. One is a grid impact, that total harmonic distortion and short circuit studies, and also that there is two things here. One, when there is a less than 11, so there is a small testing. If and if the project is around 11 to 20, there is an AC panel and the protection CT meter. And if it is a bigger than 20, we need to have the protection and feedback. So there is a three things in the testing and commissioning, depends on the project. And before this testing, there is a grid impact like the total harmonic and short circuit studies.
Okay. Thank you very much. Mr. Fabian, back to you with a question regarding the type of net metering that you have on grid. Is it net metering or net billing? And is the customer allowed to sell electricity back to the grid? And or how much is he can he cover their from their annual and electricity needs?
Yeah, thanks for that question. I can answer that. I'll try to answer it as well as I can. It's it's caused for quite some confusion, really, in Oman. But the way, and it's like a net metering, but it's not a net metering. So for the traditional auto generator plants, uh, the client purchases the plant outright in a capex model or EPC model. Then he can consume, or he is mandated to consume as much of that power as possible in house. Whatever is a surplus can be exported to the grid. Now, if it's a commercial customer who is, for example, consuming at a CRT tariff or cost reflective tariff, commercial tariff, he will export it at the same tariff in that same time. So it's really akin to real net metering. Um, if it's a residential client, he will be paying residential, or he or she will be paying residential tariff, and they can export it at CRT tariff, which is kind of like a like like a subsidy or an incentive to install solar, because the power that's injected is worth more than what they consume from the grid. So you can actually earn money, especially in winter when the ACs are off. Now, you can't take that power with you into the next year.
Okay.
So that's a bit of a restriction. And especially for the commercials, the mandated maximum capacity that they sanction you is they set it accordingly so that you have little to no surplus injection, which suits the goal of having auto generation on site or distributed solar. But on the other hand, it can restrict the client as well to increase the size of their solar system. I'm sure Suhaib also knows about this because he does the grid studies. But uh, when if you can prove that your hourly consumption is high or your base load is relatively high non-stop, even they may sanction more than the 50% of max demand, all the way up to 100% of max demand. So long that a minimum is being injected into the grid, it serves really two purposes, in my opinion. One, they state as to protect the grid stability and the hardware in the grid, also to minimize the economic burden on the grid operator. They don't want to, they're mandated by the government or by the authority to pay the consumer for the excess at that higher tariff. So it's a multi-pronged approach, which seems to work quite fine. Where it gets a little more not complicated, but if you're doing it on a leasing basis, as far as I can tell, under current regulation, you're required to install a zero feed-in device, so there is no backfeeding into the grid. So you will also not get paid for any surplus. And then it's really important, in my opinion, or our opinion, to size the system perfectly so that not too much is generated that you would otherwise be losing because it's not going to the grid.
Okay, thank you very much, Fabian, for this wonderful answer. I think we reached the end of our time. Over to you, Bashili, and big thanks to Solar Quarter for this excellent opportunity to talk about solar PV in Oman. And big thanks to Bashili and her team for wonderful support. Over to you, Bashili.
Sir, we
Thank
have
you very
received
much.
one last question.
Okay,
Can you have that? Yeah, yeah. So I'll just show on the stage.
is it mandatory to keep separate earthing for AC or DC in Oman? Uh, Fabian, would you like to answer that, or Suhaib?
Maybe
So
Suhaib can assist here because this is one of the great mysteries of solar in
Suhaib?
Oman.
Yes. For the mandatory here in Oman, yes, it is mandatory to
Yes.
have the earthing.
Okay. For
To
AC and DC, huh? Or both?
uh, for the AC side, for
For
the
the AC
DCs,
side.
it's not that much mandatory.
So,
Okay.
Habe, what I think they're trying to ask is what we always have been debating about. The point is it mandatory to have DC earth pit with separate earth rod, or you can share the DC and AC earthing?
As a best practice, I see it. The both the DC and the AC,
I tell you
both.
what we have in Jordan. We have
Well,
separate earthing pits. I will make it easier.
yeah.
Yeah. So maybe we are a little bit more mature market with over 10 years of experience and 2.7 gigawatt of installed capacities. And it is mandatory to have separate earth pits. So definitely with experience, the best practices will evolve in the developing countries. And we recommend, yeah, definitely we recommend that Oman will go towards having two separate earth pits. Yeah,
I
because
mean,
it
yeah,
seems
but it's not always so straightforward because I
yeah,
mean in Europe it's common earth. You use whatever earthing is there because the earthing of the building is very good because its foundation is earthed. You're doing better than you're putting one or two earth rods. You're getting better earthing if you mount it in the common building earth. And the question is really that what if you maybe I don't know how it is in Jordan. If the inverter itself, the body of the inverter needs to be earthed, does that require a separate AC earthing or not? Does that go also to the building earth?
Definitely the solar PV system is separate than the building earthing. So the solar PV system is totally separate.
So you
Yes,
need three earth points in reality: the building, the AC, and the DC.
correct.
And what about the lightning arrestor?
Uh, for uh, for the solar PV plants, definitely you need lightning protection, 100%. If you have a small system, rooftops, it's not mandatory. No,
Okay, thank you.
my pleasure. Okay,
Uh,
over.
the
Yes,
last question. One
yes. Go
second.
ahead,
Yeah, it's for Fabian.
Fabian. How you see solar industry in Oman compared to Europe, European country, Germany? So it's a specific question to you, Fabian.
Yes, hi, Mr. Swapnil. Thanks very much. Nice to see you here. It's a good question, especially now. Um, when I start my solar career in Austria, and the boom in Germany and Austria had already happened, and the bust had come, and 80% of the companies had gone out of business. And I was luckily working with one of the ones that was still in business, which was a testament to how well they were managing the crisis.
هذا فوبيا
Um,
هذا بس.
uh, what happened after that was it was very competitive, and regulatory authorities were providing some incentive but not enough. And then when I left, or I didn't I always had the plan to come to Oman to work in the solar industry because I'd lived here most of my life, and we have some of the best sunlight in the world. So it's a no-brainer, and there's a lot of electricity demand. Now, as you can see, Europe is experiencing a new boom in solar, large scale, small scale, medium scale, whatever, incentives. They actually have a shortage in everything. In Austria, I could pick up a tool belt and go and work as an installer in a solar system industry. I will make a lot of money just installing solar panels. That situation they are facing there now, they don't even have enough labor to do any of the work, let alone the development. So it's a bit of a shortage. They have all the money, but they don't have material, they don't have workers, and they don't have engineers. So the three major factors are failing. Only the money is there. Usually it's the other way around, yeah. So the thing is, they're experiencing a new boom, but I do see it on a worldwide scale. No matter where you are, if you have this skill set of renewable energy, specifically solar storage and everything that comes with it, you will have a nice and lucrative career anywhere you go, provided you speak the local language or English, or most places they speak in English. So I believe this is like the new petroleum engineering of the 70s and 80s, where everyone was in petroleum engineering, including my own family. They told me go and do renewable energy, and it's paying off nicely now. So I believe any market is a good one. Just Oman, yeah, it's smaller than, for example, Emirates, but we have Saudi Arabia next door. Other countries are coming up. Africa is untouched market, so there's a lot of potential in our geographic area.
Fantastic. Thank you very much, Fabian. Vishali, more questions or done?
No, no, sir.
Excellent. Over to you. Thank you very much.
Yeah. Thank you so much to all our esteemed panelists. Samiso, you were absolutely outstanding. It was a pleasure having you in such a well planned and high energy panel discussion. Thank you,
Pleasure.
everyone, for extending your time and support for the event. We promise you to come back with more exciting topics very soon. The floor is now open for networking. Thank you so much, everyone. Thank you for your support. Thank you.
Thank you.
Thank you for the invitation.